Okay, guys, here we go. Day 3, limits as x approaches c, second day. Trying to make this video again before anybody gets up in my house. Today is Sunday if you are watching it. Otherwise, maybe you'll be watching it next week sometime. Okay, so we're going to start out with a challenge. Yeah, obviously we're not rolling the die and giving out some cards here, but let's try it. So this is just based off yesterday. All right, we are going to find the limit as x approaches 7. So remember, all that means is when x tries to reach 7 from both sides, is there the same y value that it is trying to reach? So we start out right away by plugging in 7 and hoping that it works and we get an answer. If we plug in, we get 0 over 0, which again from yesterday means that there's a hole. So we need to rearrange this and make this function look different so that we can plug it in. There's no factoring here, there's no top bottom here, so I think we can all see that the only thing we can do is rationalize the denominator. So let's multiply by the conjugate of the denominator. We multiply top and bottom because that will maintain equivalency. On the top, remember, we're not going to FOIL that out because we've seen that we do wind up having some nice stuff cancel. So the bottom is dots. I'll take the first one and square it. I'll take the second one and square it. Or I should say we treat it. We can treat it like dots. Put a minus sign between them. These guys wipe out, -1. So I'm left with negative rad x plus rad 7. Make sure you use that parentheses. Now if I plug in negative rad 7 plus rad 7, right, I went over here and now I took my 7 and placed it into the new rationalized version. Rad 7 plus rad 7, how many rad 7s do you have, right? 2 rad 7. And now apply the negative on the outside. Okay, so hopefully you got that correct. So what are we going to do today? When we plug in today, we're not going to get 0 over 0, which was a hole. Instead, we're going to plug in, and we're going to wind up with a constant over 0. And we'll have to review back a little bit. When we get a constant over 0, going back again to that rational function unit, when we would graph everything without a calculator and we would look for the x-intercept, y-intercept, vertical asymptotes, horizontal asymptotes, slant asymptotes, remember holes, all of that. When we would wind up with a constant over 0, there was a vertical asymptote. Okay, so think about it logically, and we can look at the example that I'm giving you. So here's the function, x plus 3 over x squared minus 9. And then come on over here, you know, if I was in class with you, we would graph this. Now you can see here that there is a vertical asymptote at x equals 3. So if I were to do the limit by graph like we did the first day, as I come from the left, it's going to go to negative infinity, and as I come from the right, it's going to go to positive infinity. So we know that it does not exist. But that was the first day. Today we're doing this algebraically, so we're not going to be looking at the graph. But I just wanted to show you from the graph what it's equal to. Okay, so here's what we're going to do. So we are going to still try to factor, simplify, like we did yesterday, as much as we can. And then I'm going to show you. We're going to take the limit from the left and from the right. If they come out to both be positive, which I'll show you, it's going to be approaching infinity. If they both come out to be negative when I approach from both sides, then it's going to be negative infinity. And if we get different answers, which we're going to see is going to happen in this case, then it does not exist. Okay, so we'll get started. Again, so the nice thing is you start out right away by plugging in. So plug in the number 3. And we can see that we get 6 on the top, and you get 0 on the bottom. So we just say a constant over 0. When we get a constant over 0, it means there's a vertical asymptote like we saw in this picture. So it's good. So the y value is going to be pushed to either approach infinity or negative infinity. So let's try to simplify. like we did yesterday as well. So the steps are, pretty similar. I'm left with 1 over x minus 3. Okay, from here, what we're going to do, notice if I plug in the 3, I'm still left with a constant over 0, right? That's of no use to me there. So we're going to do like we did on day 1. We're going to take the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. And technically, we're taking the limit of f of x of f of x. Okay, now, when we take the limit of x approaching 3 from the left, algebraically, really what you're doing is you're taking a number that's a tiny bit smaller than 3. So a number that's a tiny bit smaller than 3 would be like 2.9. So I'll plug in 2.9. Right, if I was on a number line, here's the number 3. You want to pick something that it says we're coming from the left. So you want to pick something over here, something to the left of 3. So 1 over 2.9 minus 3 is going to produce a negative number. That's all I care about. It's going to produce a negative number. I don't care what the number is. Now let's take the limit to the right of 3. Well, to the right of 3, I'm just going to be a tiny bit bigger than 3. So 1 over, how about 3.1 minus 3? Now that's going to produce a positive number. So when we wind up with different signs, we know that the limit does not exist. Or you can use the symbol. Okay, so that's what we're going to do today. If they came out to be both negative, then it would approach negative infinity. If they both came out to be positive, then it would approach positive infinity. If you need to rewind and listen to me say all that again, please go ahead.